A very, very important concept, this one. If 6 to the power of x is a factor of 40 factorial, what is the highest possible integer value of x? Now, very often students come up with obvious answers, such as 6 or 2. These are not the correct answer. The right answer is much higher in value. Here are the steps. Look for the highest prime number in the divisor. Count the number of times this prime number appears in the factorial. So, if you are finding the highest power of 6 in 40 factorial, it's not about 6 so much. It is about 6 being 2 times 3. Imagine when you expand 40 factorial. A number such as 8 will come. A number such as 27 will come in the expansion of 40 factorial. And when they are multiplied, you see, 8 is not a multiple of 6. 27 is not a multiple of 6, but 8 times 27 is 216, which is same as 6 cubed. So see, suddenly we have 3 powers of 6 out of these numbers, which did not have a 6 in them. So it's not about the complete base. It is always about the highest prime factor of the base. So 6 equals 3 times 2. Of course, the number of 2's will be more, number of 3's will be fewer. Always count the highest power of the highest prime factor of the divisor. So it's about the number of 3's here. 40 factorial. 1 to 40, when expanded, will have 13 numbers, which are multiple of 3. So 3, 6, 9, until 39. There are 13 such numbers, but then many of them, such as 9, 18, 27, these are going to have more than one 3 in them. Therefore, figure out the number of such numbers which have a higher power of 3. So 40 divided by 3 to the power of 2, or 40 divided by 9. There are 4 such numbers which will have 2 3's in them. Then, there will be one number, 27, which has a 3 cube, or 3 3's in it. Now imagine there are 13 numbers which have 1 3 each. There are 4 numbers which have 2 3's each. 1 3 got counted here, and the second 3 gets counted here. Then there is one number that has 3 3's in it. 1 3 got counted here, 1 3 got counted here, and the third 3 gets counted here. Therefore, the answer is, quite simply, 13 plus 4 plus 1. The answer is 18. If you think this was lengthy, don't worry. A lot of it was just to explain the logic. Practically, the question can be solved very quickly. For example, if we have to find the highest power of, let us say, 15 in 100 factorial, how do we do it? First of all, we know 15 is 5 times 3. The higher prime number is 5, and therefore 5 will occur less often. Imagine when 100 factorial is expanded. Until 100, one has to move only 3 places to get a multiple of 3, but one has to move 5 places to get a multiple of 5. Therefore, 5 decides what is going to be the highest power of 15. Now, how many 5's in 100 factorial? 100 divided by 5 is 20. And then, rather than finding a 100 divided by 5 to the power of 2, or 100 divided by 25, we can simply find a 20 divided by 5, which is 4. This can be no longer divided by 5. So the answer is 20 plus 4, 24. That's how you can do it really quickly. Try these questions. Please pause the video and solve these. 7 in 50 factorial. So 50 divided by 7 is 7. Remember, keep leaving the fractional part. Next, 7 divided by 7 is 1 more. Overall, 7 plus 1. The answer is 8. Next, 5 in 50 factorial. 50 divided by 5 is 10. Then 10 divided by 5 is 2 more. Overall, 10 plus 2. The answer is 12. 11 in 150 factorial. 150 divided by 11 is 13. 13 divided by 11 will be 1 more. Overall, 13 plus 1. The answer is 14. Next, 70 is the divisor here. 70 means 2 times 5 times 7. The highest prime factor is 7 here. So consider 7. 50 divided by 7 is 7, and 7 divided by 7 is 1 more. Overall, 7 plus 1 equals 8. The answer is same as this. See, the highest power of 7 is 8, and the highest power of 70 is also 8. This is because the highest prime factor of 70 as well as is the same 7. Next, 15 in 50 factorial. 15 is 5 times 3, so it's about 5 here. 50 divided by 5 equals 10. 10 divided by 5 equals 2. Overall, 10 plus 2 equals 12. Next, 9. This is interesting. It's about finding the pair of 3's. So 50 divided by 3 is 16. 16 divided by 3 is 5. 5 divided by 3 is 1. This adds up to 22, but 22 is not the correct answer. It's about 9. 9 means 3 square. So to get 9, we need a pair of 3's. So the answer is not 22. The answer is 22 divided by 2, which is 11. 11 is the correct answer. Next, 16. Once again, 50 divided by 2 is 25. 25 divided by 2 is 12. Of course, I neglect the fractional parts every time. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 2 is 1. Added up, we get 47. However, 47 is not the correct answer. 47 is the highest power of 2. For 16, we need groups of 4 2's. How many such groups are possible? The answer is 47 divided by 4. Always ignore the fractional part. The answer is 11. That's our answer. Next, 63. Now 63 is 3 times 3 times 7. One may argue that 2 3's will occur later. 1 7 will occur sooner. You can always judge it. See 1 times 2 times 3, 4, 5, 6, 7, until 50. So to get 1 7, one has to travel 7 places. To get 2 3's, 1 3 comes here, second 3 comes here. So to get a pair of 3's, one has to travel only 6 places. So it is 7 that decides the answer. So 50 divided by 7 is 7, and 7 divided by 7 means 1 more. 7 plus 1. The answer is 8. Now, in case you are confused about which factor to choose, I would suggest that find answer using both the values and then choose an answer that is smaller. For example, in this case, if you were confused, try to get answer using 3 as well. 50 divided by 3 is 16. 16 divided by 3 is 5. 5 divided by 3 is 1. The sum turns out to be 22. And then pairs of 3's. So 22 divided by 2, the value is 11. Therefore, if I choose 3 as the deciding factor, or pair of 3's as the deciding factor, I get 11 as the answer. If I choose 7 as the deciding factor, I get 8 as the answer. Remember, always the smaller value wins. So the answer would be 8 and not 11. So whenever confused, find multiple answers and choose the smallest value. This was the concept, friends. GMAT shots are deliberately kept brief. For an elaborate explanation, please watch the Stage 1 conceptual videos in our program. Thanks for watching.